Uh, Today we have some numerical questions on simple harmonic motion. You can see the first question on the screen. One end of a light spring having spring constant K is equal to 18 Newton per meter is attached to a rigid support a mass of 0.15 kg is suspended from other end of the spring. A student pulls down it such that the extension spring increases by 4 cm. So this extension done by pulling the spring is amplitude. Maximum displacement amplitude 4 cm, that is 0.04 meter. The student now releases it. As a result, the mass performs simple harmonic motion. Calculate the maximum acceleration and time period of simple harmonic motion. So for spring, the time period is given by 2 pi root under m mass by spring constant. Putting the values, and substituting and solving, we get 0.57 second. Similarly, maximum acceleration. So maximum acceleration is given by omega square a. So first we need to calculate omega. Omega is given by 2 pi by t, which is equal to 2 into 3.1415 by time period 0.57. And after solving this, we get the value 2 into 3.1415 divided by 0.57, 11.022 radian per second. And after getting omega, we can calculate maximum acceleration as omega square a, that is 11.022 square into amplitude 0.04. On calculating, we get 4.8 meter per second square. So this is the solution of first equation. Now let us move to the second question. Here is the second question on the screen. A simple pendulum of effective length 4 meter swings with an amplitude of 0.2 meter. Compute the velocity of pendulum at its lowest point. So velocity at its lowest point means at mean position, which is maximum velocity. So we must know that maximum velocity formula is omega a. First we need to calculate omega. Now for a pendulum, omega is equal to z by L, that is 9.8 by 4. This comes to be 1.565 radian per second. And now then maximum velocity can be obtained as omega a, that is 1.565 into 0.2. This is obtained as 0.32 meter per second. You can see the solution of the second question on the screen. Now time for third question. A boy of mass 8 kg, a bob of mass 8 kg performs simple harmonic motion of amplitude 30 cm, which is equal to 0.3 meter. Now, and the restoring force is 60 newton, which is maximum force. Now calculate time period, maximum acceleration and kinetic energy. Now first we need to calculate force constant. So maximum force is given by as force constant into amplitude 60 is equal to force constant into 0.3. This gives force constant as 200 Newton per meter. Then now time period is calculated as 2 pi root under m by k. Let us put the value 2 into 3.1415 into mass 8, spring constant, force constant 200. Solving this, we get almost about equal to 1.256 second. So time period is calculated. Now we need to calculate maximum acceleration. So we have formula for maximum acceleration, a max as omega square a, but here since maximum force is given, we can calculate maximum acceleration in a simple way, maximum force by mass, that is 60 by 8, which is equal to 7.5 meter per second square. And at last, kinetic energy. Now we have left a little bit of space because next question is below it, below the line. Kinetic energy. So formula for kinetic energy of simple harmonic motion is half into spring force constant into a square minus displacement square. Displacement is 12. So 1 by 2 force constant 200 into amplitude 0.3 square, and value of x is 12 cm, that is 0.12 meter, 0.12 square. This on calculation gives 7.56 joule. So third question is solved and is on your screen. Now fourth question. A particle of mass 0.25 kg oscillates with a period of 2 seconds. So here mass is 0.25 kg and we can see time period is 2 seconds. If the greatest displacement means amplitude is 0.4 meter. Find the what is the maximum kinetic energy. So here maximum kinetic energy is given by 1 by 2 Ka square, and spring constant or force constant K is m omega square. So first we need to calculate omega. Omega is equal to 2 pi by t. Since time period is given 3.1415 radian per second. I'm putting this value on kinetic energy maximum 1 by 2 0.25 into 3.1415 square into 0.4 amplitude square, and on solving we get about 0.2 joule. The fourth question is also solved. Now time for fifth question. Calculate the period of oscillation of a simple pendulum of length 1.8 meter with a bob of mass 2.2 kg. If the bob of this pendulum is pulled aside a horizontal distance of 20 cm and released. So this statement is for amplitude. 20 cm means 0.2 meter. And what is the kinetic energy at lowest point? So at lowest point kinetic energy is maximum, and this is given by 1 by 2 m omega square a square. We have mass, we have amplitude, and now omega. So let us put expression for omega over here, g by l, because in formula omega is equal to root under g by l. Now let us put the values into 2.2 into z 9.8, length 1.8, and amplitude 0.2 square. Putting all these values and solving, what we get, this is equal to 0.245 joule. So question number 5 is also solved. And now question number 6. Question number 6 is something analytical. So this is also the last question of this video. Simple harmonic motion is defined from periodic function like sine or cosine function. State the basic equation of motion for a body executing simple harmonic motion. So here the basic equation of motion executing SHM, simple harmonic motion. So differential equation of simple harmonic motion is d square x by dt square plus omega square x is equal to 0. And the solution of this equation, the solution of this above equation is x is equal to some constant a sine omega t plus phase. So this is the equation for displacement of the particle in simple harmonic motion. The second question is find expression for velocity and acceleration of the particle. So now we need to calculate velocity. By definition, velocity is the rate of change of displacement, that is dx by dt, derivative of displacement with respect to time. So d by dt, value of x is sine omega t plus is 5, and let us calculate the derivative. So a is constant, the derivative of sine cos omega t plus phi, and since omega is in front of t and derivative is with respect to t, so omega comes outside. Finally, this is the expression for velocity. And now we know that cos omega t plus phi can be written as 1 minus sine square omega t plus phi under root. In such case, b is equal to a omega root under 1 minus sine square omega t plus phi. Taking a inside, a square minus a square sine square omega t plus phi. So finally this becomes a square minus, and a sine omega t is x, so x square. This is the expression for velocity in simple harmonic motion. Similarly, acceleration is dv by dt. So derivative of velocity, and velocity is a omega cos omega t plus phi. A omega, the derivative of cos is sine. When cos changes to sine, there is minus, and since omega is coefficient of t, omega comes outside. So minus omega square a sine omega t plus phi, and again the term in the bracket is x, so therefore a is minus omega square x. This is acceleration of simple harmonic motion. Now, third question. The tip of turning fork goes through 550 complete vibration in 1 second. 550 complete vibration in 1 second. Find the angular frequency, that is omega, and time period t. So this statement, 550 complete vibration in 1 second. 550 vibrations in 1 second. This gives a frequency 550. Therefore time period is 1 by f, 1 by 550. This gives 0.0018 second. And now we need to calculate angular frequency. Omega is 2 pi f, that is 2 into 3.1415 into 550. This on calculation gives about 3455 radian per second. Hence I have selected 6 questions for this video, and I have solved all those questions. Happy learning.